Hello and welcome. In this video, we will see the concept of serializability, conflict serializable, and view serializable. After watching this video, you should be able to explain serializability and determine whether the schedule is conflict serializable or view serializable. The concept of serializability is used to identify which schedules are correct when transaction executions have interleaving of their operations in the schedules. So what do you mean by schedule? It is the order of execution of the transactions in a predefined order. Now let us see what is serializable schedule. A schedule S of n transactions is serializable if it is equivalent to some serial schedule of the n transactions. Since serial schedule executes the transactions sequentially and it does not allow concurrency, serializable schedule was introduced. Executing the transactions in a concurrent manner will improve our system performance. Also, we want our transactions to execute in isolation, which means if multiple transactions are being executed concurrently and try to access a shareable resource at the same time, the system should create an order in their execution. The only reason for this is that there should not be any anomalies in the value stored at the shareable resource. But there are possibilities that the execution of transactions in a concurrent manner would affect the database. So we want our schedule to maintain both concurrency and isolation. Now let us take an example and check for serializable schedule. Consider a schedule S shown on screen, where the data item for read A operation in T2 is executed after updating write A operation in T1. Similarly, read B operation in T2 is executed before updating write B operation in T1. Now let us consider three schedules S1, S2 and S3 and check whether they are serializable with S or not. In schedule S1, read B operation in T2 is executed after updating write B operation in T1. Hence, we can say that the schedule S is not serializable with S1. In schedule S2, read A operation in T2 is executed before updating write A operation in T1. Hence, we can say that schedule S is not serializable with S2. Whereas in schedule S3, read A operation in T2 is executed before updating write A operation in T1. And read B operation in T2 is executed before updating write B operation in T1. Therefore, we can say that schedule S is serializable with S3. There are two important aspects of serializability: conflict serializability and view serializability. Conflict serializability deals with detecting whether the instructions are conflicting in any way and specifying the order in which these two instructions will be executed in case there is any conflict. A conflict arises if at least one or both of the instructions is a write operation. If the schedule is conflict equivalent to serial schedule, then the schedule is conflict serializable. Two schedules S1 and S2 would be conflicting if they have the following properties. Both belong to separate transactions. Both accesses the same data item. At least one of them is write operation. Now let us take an example for conflict serializability. Consider a schedule S1 which performs read and write operations for data item A in T1 and then performs read and write operations for data item A in T2. Again, S1 performs read and write operations for data item B in T1 and then performs read and write operations for data item B in T2. So, what will be the serial schedule for S1? We have to check whether the transactions in S1 is conflict equivalent with some other serial schedule. If yes, then it is conflict serializable. Now we shall take serial schedule as S2 and first perform all the read and write operations of S1 for data item A and B in T1 serially. Similarly, perform all the read and write operations of S1 for data item A and B in T2 serially. Now we have to check whether both the schedules are conflict equivalent or not. If they are conflict equivalent, then we can say that S1 and S2 are conflict serializable. Now let us see which all operations in schedule S1 are in conflict with schedule S2. The first operation in S1 is read 1 of A in T1 is followed by write 2 of A in T2. Now let us see whether it is the same in S2. Read 1 of A in T1 is followed by write 2 of A in T2. So this condition is true in both the schedules. The next operation in S1 is write 1 of A in T1 is followed by write 2 of A in T2 and read 2 of A in T2. Even in S2, write 1 of A in T1 is followed by write 2 of A in T2 and read 2 of A in T2. So even this condition is true in both the schedules. Let us see the next operation in S1. Read 1 of B in T1 is followed by write 2 of B in T2. Now let us see whether it is the same in S2. Read 1 of B in T1 is followed by write 2 of B in T2. So this condition is also true in both the schedules. The last operation in S1 is write 1 of B in T1 is followed by write 2 of A in T2 and read 2 of A in T2. Even in S2, write 1 of B in T1 is followed by write 2 of B in T2 and read 2 of B in T2. So even this condition is also true in both the schedules. Hence, we can say that schedule S1 and S2 are conflict equivalent. Therefore, S1 is conflict serializable with S2. Now let us look at view serializability. Two schedules S1 and S2 are view equivalent if the following conditions are met. If T1 reads the initial value of the data item in S1, then T1 in S2 must also read the initial value of that same data item. If T1 in S1 writes a value in the data item which is read by T2, then T2 in S2 must also write the value in the data item before T2 reads it. If T1 in S1 performs the final write operation on that data item, then T2 in S2 must also perform the final write operation on that data item. So, if the schedule is view equivalent to serial schedule, then the schedule is view serializable. This is similar to what we studied in conflict serializable schedule. So we can say that every conflict is serializable schedule is also view serializable schedule, but not vice versa. This means that a view serializable schedule cannot be same as conflict serializable schedule. To understand view serializability, let us take the similar schedules of S1 and S2 which we took for conflict serializability. According to the conditions of view equivalent, the first condition is data item A read by T1 in S1 is the same as S2 because T2 also reads the same data item A in S2. Similarly, for the first data item B read by T1 in S1 is the same as S2 because T2 also reads the same data item B in S2. So, this condition is true. Let us check for the second condition. If a transaction is reading a data item written by some other transaction, then the order of view equivalent should be maintained. Continuing with our example, T2 reads by a data item A in S1 which is written by T1 in A. This is same in S2 as well, where T2 reads a data item A which is written by T1 in A. Similarly, T2 reads a data item B in S1 which is written by T1 in B. This condition is also same in S2 as well, where T2 reads a data item B which is written by T1 in B. Now the last condition is to check for the final write operation on that data item. So the final write operation for data item A in schedule S1 is performed by T2. This condition is also same as the final write operation for data item A in schedule S2 is performed by T2. Similarly, the final write operation for data item B in schedule S1 is performed by T2. Even this condition is also the same as the final write operation for data item B in schedule S2 performed by T2. Hence, we can say that schedule S1 and S2 are view equivalent. Therefore, S1 is view serializable with S2. So far, we saw the transactions in serial schedule S2 is T1 followed by T2. Now, let us see what will happen if the transactions in T2 is followed by T1. Consider this schedule as S3. According to the first condition of view equivalent, S1 reads the data item A in T1, but S3 is read by T2. So the condition is failed here. Let us see whether it satisfies the second condition. T2 reads a data item A in S1, which is written by T1 in A. But this is not the case with S3. Hence, we can say that schedule S1 and S3 are not view equivalent. Let us do a quick recap of this video. Serializability is used to identify which schedules are correct when transaction executions have interleaving of their operations in the schedules. A schedule is serializable if n transactions is equivalent to some serial schedule of that n transactions. A schedule should maintain both concurrency and isolation in executing the transactions in a database. There are two important aspects of serializability: conflict serializability and view serializability. We have to know the properties of conflict serializability to check whether the schedule is conflict equivalent to serial schedule, and the properties of view serializability to check whether the schedule is view equivalent to serial schedule. Thank you for watching this video.